Welcome to Study Loop.
Okay, so in this question, we want to show that ceiling of x minus 2 is the closest integer to the number x, except when x is midway between two integers, when it's the smaller of these two integers. So what does this question even mean? So what it means is suppose we have two integers, n plus 1 and x. Oh, sorry, n. Then what we want to show is that when x is closer to this number, so I'll put this n plus by a half. So when x is close to this number, then the ceiling of x minus by a half is equal to n plus 1 when x is in this range because it'll be closer to this number. Otherwise, x minus by a half is equal to n. This is essentially what the question is asking, just asking it in a very convoluted way. So to do this, we'll first let n plus by a half be less than x, less than or equal to n plus by 1. So in this case, then x is closer to ceiling of x minus by a half. Then if you do the subtractions, you'll do n is less than x minus by a half, less than or equal to n plus by 1 over 2. Then by definition of ceiling, we'll take n plus 1 because x minus half is less than n plus 1 over 2. So x is going to be somewhere over here, and we'll take the ceiling of it, so we'll take n plus 1. So ceiling of x minus by half is equal to n plus 1. So we've proven the first result. The next result that we have to prove is then when n is less than or equal to x is less than or equal to n plus by a half, then this implies that x minus by a half is equal to the smaller of the two number integers, which is n. So to do this, we do the subtraction once again. So n is less than or equal to n minus a half is less than or equal to x minus by a half, less than or equal to n. So what this means then is if we have n minus 1, n minus by a half, we have x is somewhere in between this range. And because we're taking ceiling, we're going to take it to n. So then ceiling of, so this is n plus 1, n minus by a half is equal to n as required.